In this video, we're going to talk about trigonometric equations with multiple angles. It sounds kind of complicated, but really it's just one step. So far, every trig equation we've had is just at a single x on the inside. But what happens if there's something more complicated on the inside? What are we going to do? All right, well, just like when we were dealing with equations of quadratic type, we can make our own substitution to create a simpler equation we know how to solve. So when we're doing quadratic type equations, we did a substitution to turn it into just a quadratic that we could solve doing the quadratic formula, factoring, whatever. We're going to do the same thing here. We want to use a substitution to make the problem simpler at first to solve, and then go back and undo the substitution. So right now, this problem is more complicated than our normal trig expressions because there's a 4x on the inside instead of just an x. So when there's a 4x on the inside, our unit circle doesn't apply anymore because the angles are all going to be different. But what I can do is I can make u 4x. Again, I always do u for substitution because of something that happens in calculus. You can use whatever letter you want as long as it's not x. Heck, you could use a symbol. You could do heart equals 4x as long as you write it every single time. But this turns this into cosine of u equals negative square root of 3 over 2. And then this is an equation we know how to solve because just a basic cosine, it's a different letter, but it's still just cosine of something, equals negative square root of 3 over 2. And I don't have the unit circle on the screen, but you have it. You can pull it up. Cosine is negative square root of 3 over 2 at 5 pi over 6 and 7 pi over 6. And don't forget, if I'm solving a trig equation, I have to include all solutions. So I have to have the plus 2 pi k. And now I have to remember, well, I don't want to solve for u, I want to solve for x. So u is actually a placeholder for 4x. And how do I get rid of the 4 so I can get x by itself? You can divide by 4. In this case, because there's a fraction involved, I think about multiplying both sides by 1/4. All right, so now I'm going to get x all by itself. This first angle is going to change from 5 pi over 6 to 5 pi over 24. 2 pi over k, the 2 and the 4 are going to become a half. It's going to be pi over 2k. All right, so just multiplying everything by 1/4, 7 pi over 24 plus pi over 2k. All right, so here's the most important thing when you're doing these is that you put the plus 2 pi k's, you solve all solutions to the u part, the substituted part, and then you're going to have a different repeating factor here because this changes the period of how often your cosine repeats. It's something we learned about when we learned about graphing. So yeah, just notice that some people, the mistake they'll have is they won't have these plus 2 pi k's here, and they'll throw them at the final answer. But then the repeating part of your answer is wrong. So you put them here, and they're also included in the solving for x part. Here's an example. All right, the 1/2 x, there's something more complicated in here. So I'm going to make u 1/2 x. It's going to be 2 sine of u minus 1. We know when we get an equation like this, our first step is to isolate the trig function. So I'm going to add 1 to both sides and divide by 2. And again, look at the unit circle. Sine is 1/2 at pi over 6 and 5 pi over 6. All right, but we don't want to solve for u. We want to solve for x. So this is 1/2 x is equal to u. You don't have to do it in one line like this. You can rewrite it, but that's just run out of room. So u is 1/2 x. Now I want to get this x by itself, so I'm going to do that by multiplying both sides by 2. Okay, remembering multiplying everything by 2. All right, so now the x is going to be by itself. Pi over 6 times 2 is going to be pi over 3 plus 4 pi k. X is by itself. This is going to be 5 pi over 3 plus 4 pi k. So now I know the answer. I know how often my answers are going to repeat. That's the solution to my problem. All right, so here's the big problem. That's kind of like the culminating thing of a lot of algebra 2, a lot of trig stuff, this stuff of quadratic type. All right, not only do we have a thing of quadratic type, we have cosine squared and then cosine. we also have an extra thing in the parentheses. All right, so first, this is a quadratic type problem, so we're going to make u the thing that's being squared, or the thing by itself, cosine of 2x. So now my problem becomes 2u squared minus u minus 3 equals 0. I want to factor this, so I have to add to -1, multiply to -6. That is what, -3 and +2. So I do my splitting method. I factor out. I separate. And I solve for u. All right, so all of this is just solving my quadratic, something you've done plenty of times by now, by the time you've gotten to this lesson. All right, something else you've done for a few lessons is undoing the substitution. So I know cosine of 2x is 3/2, and cosine of 2x is -1. 3/2 is 1.5. And the biggest cosine ever gets is 1, so this left-hand part's not possible, because cosine, no matter what's on the inside of cosine can never be bigger than 1. But on the right side, cosine can be -1/2, so here I have a problem where I have something more complicated inside of cosine. So this little problem here, that's part of this big problem, is like the ones we did earlier in the video. So here I can do, I don't know, I don't want to do u again because we already used a u. Let's do, well, we've already done u, let's do w equals 2x. All right, so now this is cosine of w equals -1. This I can solve using the unit circle because I just have a single variable in my parentheses. W is, cosine is -1 on the left-hand side of that unit circle at pi. But w is actually a placeholder for 2x, so now I can multiply both sides by 1/2, divide by 2, it's the same thing. And my very final answer is now I have x all by itself. Pi times 1/2 is pi over 2. 2 pi k times 1/2, the 2's cancel, and I get pi k. Right. So if you can follow along that problem and kind of understand each step, you are in an absolutely great place in terms of your understanding of Algebra 2. You can do a substitution for a equation of quadratic type. You can solve a quadratic. You can recognize trig functions that don't have an equation. You can solve a trig equation with a multiple angle, and you can get your final answer. All right, that's a lot of great work if you can follow along with this and recreate it. All right, but for you to try on your own, make it a little bit simpler, just the multiple angle, sine of 10x equals the square root of 2/2. All right, so go ahead, pause the video. I'll show you the answer in 3, 2, 1. All right, and here's the answer. So you make u 10x to make it simpler. You use your unit circle to find the answer for u. You use a placeholder, so I need to get rid of that 10 by multiplying everything by 1/10, and then just simplifying to get your final answer. All right, so again, just another way to use substitution to make a problem simpler before you solve it. So we're going to substitute inside the trig function to make it just a single letter in our trig function, and that lets us use our unit circle to solve the equation. Don't forget, when you're solving that simplified equation, you can put your plus 2 pi k there. And then after you've done that, then you replace u and get x by itself.